How would you experience a sunrise on the Jovian moon Io, or on an exoplanet in a completely different corner of the galaxy? Sunrises are not the same everywhere. Even the colors are quite different in other systems than they are here. On some worlds, 3 suns rise or they remain forever dark. We reach for distant worlds. Today, we dream of colonizing Mars, and one day astronauts may also set foot on distant moons like Titan. In these worlds, nothing is like it is on Earth. Even the sun looks quite different from Mars or Pluto than it does from Earth. We start an exciting journey to 8 worlds and experience 8 sunrises from completely different perspectives. The sunrise on Io, fire and brimstone in the sky. Imagine standing on the rugged volcanic surface of Jupiter's moon Io. The landscape around you is surreal. Frozen sulfur deposits color the ground in shades of yellow, red, and orange. Volcanoes and lava fields rise up everywhere. Some of them hurl huge fountains of molten rock hundreds of kilometers into the sky. At sunrise, you turn your gaze to the east. Slowly, the horizon turns a deep blood red. Suddenly, a narrow, glistening bright strip of light appears on the horizon. Io's thin, almost non-existent atmosphere can hardly scatter the light, so the sun rises as a dazzling white fireball over the edge of Io's rugged plains. But the most impressive thing is not the sun itself, but Jupiter, which towers above you as a gigantic gas ball. The cloud-covered planet, which appears almost 40 times larger in Io's sky than our moon on Earth, dominates the scene. From Io's surface, you can see the swirls of colorful storms and eddies with the naked eye, while other moons pass by like small satellites near and far. A sunrise on Io is not gentle or romantic. It resembles a seething inferno of fire and ice. Despite its raw nature, the moon would be a potential destination for humans. The rocky landscape and gravity would probably make a short visit possible. However, the moon would be too inhospitable for life and permanent residence. The proximity to Jupiter's extreme magnetic field alone would be unbearable for us humans for long. Sunrise on Titan, eternal twilight and icy landscapes. Titan, Saturn's largest moon, welcomes you with a scenery that would seem strange and yet somehow familiar to a human being. The landscape resembles rugged mountain or desert areas like the Caucasus or the Gobi Desert. But unlike on Earth, you would be surrounded by a thick, orange-colored atmosphere. At sunrise, the sky is bathed in a golden twilight. Nevertheless, you would never be able to see the fireball that gives us our lives on Titan. The sun would remain a blurred and vague idea for the inhabitants of Titan. When Titan's dense methane and nitrogen clouds do clear, a soft, diffused light might seep through on the horizon. The day on Saturn's moon remains foggy and mystical, almost as if you were experiencing a thick orange-brown layer of smog. On Titan's surface, you would see vast plains of frozen methane and deep black hydrocarbon sand dunes. In the distance, you might see the dark surface of a liquid methane lake. The methane waves would glisten strangely in the dim sunlight. The air would probably be completely still, and if a breeze did blow, it would be freezing. Sunrise on Pluto, a pale light at the edge of eternity. Now we're on Pluto, the smallest planet at the edge of the solar system. Imagine standing in a frosty, alien landscape, looking at wide dunes of frozen nitrogen and rugged mountains of water ice. If you really were in this world before sunrise, you would not be able to see your hand in front of your face. The air is so thin that it almost does not exist, and the temperatures of minus 230 degrees Celsius would only be bearable for a short time. There is an eternal, almost eerie silence. At sunrise, the horizon begins to glow very gently in the distance. The sun is not a blinding fireball, but a bright, faintly sparkling point. Even at the best of times, sunlight on Pluto is about 250 times weaker than on Earth. Nevertheless, the distant light of the sun brings a touch of warmth and color to Pluto's eternal darkness. Presumably, the sun melts parts of the ice layers in Pluto's summer, and it may even snow. If you were to look at the sky on such a day, you might notice a delicate bluish haze. The play of colors would remind you a little of the distant Earth, except that it would be much finer and infinitely more fragile. In the vicinity of Pluto, you could sometimes see Charon, Pluto's largest moon. It's almost as large as Pluto itself and appears huge in the sky. Similar to our Earth's moon, you would only ever see the same side of Charon due to its bound orbit. Sunrise on Kepler 22b, a new day in an Earth-like world. Kepler 22b is one of the most Earth-like exoplanets currently known to be in the habitable zone of a Sun-like star. How would a new day begin on a distant world that could theoretically harbor life? The star Kepler-22 would slowly bathe the sky above you in soft blue tones. Depending on which gases dominate the atmosphere, green or violet hues would be visible. On Kepler-22, there could be landscapes such as oceans, forests, or wide plains. The sun of Kepler-22b is a bit smaller than our sun, and during the day it would bathe the alien world in a soft golden green glow. Due to the larger distance, the life-giving fireball would rise only slowly over the horizon. If there is life on Kepler-22b, these beings would probably experience only a very diffuse and soft light during the day. Depending on whether Kepler-22b has a dense atmosphere or oceans, the sun could cast a shimmering play of colors on pronounced water surfaces or alien vegetation. Sunrise on Proxima Centauri b, red glow in an eternal twilight. Welcome to Proxima Centauri b, a planet orbiting the star closest to our sun. For a long time, Proxima Centauri b was considered a hot candidate for the discovery of life beyond Earth. The Earth-like planet orbits a star that is slightly weaker than our sun and is only 4.24 light-years away. We already know that Proxima Centauri b orbits its star in a bound orbit. This means that the world has a day side and a night side, so we would only experience a real sunrise in the transition zone between eternal brightness and eternal darkness. At the beginning, a somewhat diffusely glowing ball would slide over any mountainous landscapes. When the star reaches its highest point, it would make even the moderate edge zones of Proxima Centauri b glow. The colors would probably bathe the landscape in a blood red, almost eerie light. The star's light flares and radiation bursts could cause the colors to flicker irregularly, and the sunlight would resemble a pulsating sky. Sunrise in the Small Magellanic Cloud, morning light with a view of the Milky Way. What does sunrise look like in one of our neighboring galaxies? The Small Magellanic Cloud is a dwarf galaxy hot on the trail of our Milky Way. Unlike our home galaxy, the small cloud is not of a higher order. It is an irregular and wild collection of stars, gas, and intergalactic streams. A sunrise here would be unlike anything you know. The sky would never be empty or dark. It would always be filled with glowing nebulae and strange arcs of light. In the distance, you would see the familiar band of the Milky Way. Seen from the Small Magellanic Cloud, our home galaxy is a huge, arc-shaped structure in the sky. If the first sun were to rise in our fictional world, its light would refract through the dense gas, bathing everything in a soft orange glow. Unlike in our galaxy, the stars in the Small Magellanic Cloud are younger and hotter. A sunrise in the Small Magellanic Cloud would be mystical, full of contrasts and movement. Some sunrises might appear in a bluish, icy glow, while others rise with a deep, reddish glow. Sunrise in the Orion Nebula, light in a cosmic birthplace. Forget everything you know about sunrises. In the Orion Nebula, a gigantic star-forming region, there is no single horizon, no calm sky, and no fixed landscape. Instead, we would find ourselves in a huge, colorful cloud of gas and dust. At a central point, we would theoretically see millions of glowing stars in all stages of development. There is no gentle dawn here. Instead, newborn suns would suddenly and explosively break through the dense fog. The rays of the young stars pierce the darkness in a play of colors ranging from white, blue, and orange. Gas clouds still waiting to give birth to stars could contribute bright green, red, and violet, causing a dance of colors and radiations. The Orion Nebula really resembles a brightly colored stellar nursery and is one of the most interesting places in the universe. The color play of the young stars would be interrupted by the extreme rays of jets. These extreme radiation bursts originate in the interior of the gas clouds, where young stars absorb more and more mass and begin to radiate ever more strongly. In this stellar factory, sunrise is not a single moment, but an endless spectacle of light and energy. Sunrise in NGC 6544, a world without night. We could experience a similar spectacle in the globular cluster NGC 6544. This dense cluster of stars is the opposite of the Orion Nebula. It's home to the oldest stars in the galaxy. They have been circling close together for eons. If we were standing here on a fictitious planet in the middle of this cluster, you could see a breathtaking sky. The night would never be completely dark. Thousands of stars would glow above you in different colors. The colors would also be a bright blue, soft yellow, and intense red. The stars are so close together here that the sky would always be bathed in a golden glow. But then the spectacle slowly begins to change. A huge, old star would slowly rise over the horizon. Its reddish light would mix with the rest of the sea of stars and dominate the play of colors for a while. Then a second, a third, and even more suns would follow. Instead of a single sunrise, you will experience a flood of rising stars in this globular cluster, transforming the sky into a firework of colors. Sunrise in ARP 272, dawn in galactic chaos. ARP 272 is a massive collision of two galaxies, performing an intergalactic dance of stars, gas, and dark matter. If you were standing on a planet here, you would witness cosmic chaos unfolding over millions of years. The first sun would slowly appear on the horizon, but it would not be alone. In this devastated region of the universe, dozens of nearby stars could rise one after the other in the sky. Then, you see something that could never be seen anywhere else. Brightly glowing gas bridges stretching millions of light years across. As the two galaxies tear each other apart, they pull huge streams of stars and dust with them. The result is a multi-sunrise of colorful swirling nebulae in blues, reds, and golds.